Have you ever asked yourself, when are we ever flying back to the moon? Until we do decide to fly back to the moon, let's sit here and discuss what we know about our lunar neighbor so far. In the first episode of the Moon Secrets series, we discussed the most popular moon origin story, the giant impact hypothesis. In the second episode, we talked about the close relationship and deep dependence of Earth to the moon, and the repercussions that would happen if that relationship breaks. Today, we dive further into what we know and what we have discovered on the moon. From the moon's water-ice-filled poles and its powerful volcanic activity, up to the different bewildering structures we've seen on it so far. You may think you know everything there is to know about our closest celestial neighbor, but trust me, there are secrets waiting to be uncovered that will truly blow your mind. I'm talking about something even more fascinating than just craters and dust. Did you know that in the shadowy depths of the moon's polar regions, there lies hidden treasure? Yes, I'm talking about frozen water ice. And it's not just a tiny bit. Scientists have discovered significant deposits locked away in craters that never see the sun. So, how did we come to this incredible discovery? First off, let's talk about why this discovery matters. For decades, scientists and aspiring astronauts have gazed at the moon with a shared dream: to establish a permanent human presence there. But this dream hinges on one crucial resource: water. Why? Because water isn't only crucial for drinking, it's essential for sustaining life and can even be converted into fuel for long journeys into space. Now let's rewind to a few years ago. In 2009, NASA's L-Cross mission kicked things off by impacting a spacecraft into the moon's south pole and sending back valuable data. But it wasn't until later missions, particularly with the help of satellites like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, that we received robust evidence of water ice in those shadowy craters. Picture this. The moon's poles are like frozen vaults with craters that have not felt the warm rays of the sun for billions of years. These areas are incredibly cold. Think temperatures that can drop to minus 250 degrees Fahrenheit. That extreme cold allows water molecules, when they land there, to stick around instead of evaporating into the emptiness of space. Scientists believe that this water, essentially ice, could be broken down into hydrogen and oxygen, providing the necessary ingredients for rocket fuel. How amazing is that? We could potentially fill our tanks right on the moon and launch further into space. This means Mars might not be as far out of reach as we thought. So what's next? Well, the Artemis program, which aims to land humans on the moon again by the mid-2020s, is our next big leap in exploring these regions, and the knowledge we gather may shape the future of interplanetary travel. But the moon's hidden secrets don't just revolve around ice. The findings raise fascinating questions about our universe's history. With water ice, what other mysteries could the moon hold? Could there be unknown resources we haven't discovered yet? What if there's a deeper geological story waiting to be unraveled? So, as we stand on the brink of new discoveries, it's crucial for us to keep looking up. The moon is more than just a bright object in our night sky. It's a key that could unlock the future of human exploration beyond Earth. Can you imagine what we'll discover next? When we gaze up at the moon, we see its beautiful gray surface adorned with craters and maria, those dark, flat areas formed by ancient volcanic activity. But did you know that scientists have discovered intriguing signs that suggest these volcanoes might have erupted much more recently than we ever imagined? Recent studies, utilizing data from missions like NASA's Lunar Reconnaissance Orbiter, indicate that some of these volcanoes might have been active as recently as 1 billion years ago. That's right, only a tiny fraction of the Moon's history. This is a radical shift from the age-old idea that the Moon is a cold, dead world. So, what's the evidence? Let's talk about the Moon's volcanic features known as volcanic domes. These dome-like structures were formed by relatively gentle lava flows, which paint a picture of a more complex and dynamic volcanic history. One of the most surprising finds comes from the Apollo missions, where astronauts collected samples of volcanic rocks. Analysis of these rocks is revealing clues about the Moon's volcanic past, such as gas inclusions that point to explosive eruptions. Imagine, 1 billion years ago, the Moon was an intense, volcanic world, an environment that fostered magma flows and eruptive clouds. It changes everything we know about its history. But why does understanding volcanic activity on the Moon matter? Well, for starters, it could hold crucial information for future lunar exploration. Knowing where these ancient volcanoes are and how they erupted might help future scientists and astronauts as they plan their missions. Volcanic materials like basalt could even serve as a resource for building structures or creating fuel. Moreover, exploring volcanic features gives insight into not just the Moon's history, but also the geological activity of other celestial bodies. This knowledge helps us sketch a broader picture of how our solar system formed and evolved over billions of years. The Moon might seem like a dull, gray rock to some, but it's a treasure trove of astonishing secrets. Firstly, let's talk about the infamous lunar swirls. These mysterious, light-colored patterns appear in various places across the Moon's surface, almost like cosmic graffiti. Matter of fact, one of the most striking swirls is the Reiner Gamma, a unique feature that stands out starkly against the surrounding darker terrain. But what causes these intriguing patterns? There are a few theories out there. One prevailing theory suggests that these swirls are the result of the Moon's interaction with the solar wind, particles emitted by the Sun. The swirls seem to be formed by the magnetic anomalies in the Moon's crust, which interact with the solar wind and shield certain areas from being weathered by it. Because of this, they retain their brighter appearance, but there's still so much we don't know. Now, let's shift gears and talk about another fascinating lunar mystery, mass concentrations, or otherwise known as mascons. The Apollo missions revealed these mascons, hidden beneath the lunar surface when astronauts returned with data that can only be interpreted as a gravitational anomaly. Essentially, these mascons can affect the trajectory of spacecraft orbiting the Moon. Imagine trying to land on the Moon and suddenly feeling a gravity spike that throws off your calculations. Scientists speculate that these mascons are the result of ancient lava flows solidifying beneath the surface and altering the gravitational field. So the next time you look up at the Moon, remember, it's not just a beautiful rock orbiting our planet. It's a complex, fascinating world filled with mysteries waiting for us to unravel. And here's a thought. What if some of these swirls and mascons could contain clues about the history of our solar system? What if they hold secrets to life beyond Earth? The possibilities are endless. Remember, the universe is vast, and so are its secrets. And our nearest and closest neighbor, the Moon, is no exception to it. If you enjoyed this video and the series The Moon's Secrets so far, please like and share this video. And don't forget to subscribe to Why on YouTube.